You have been calling it the wrong name your entire life. Every sidewalk you have walked on, every road you have driven, every foundation beneath every building you have ever entered. To you, that gray material is cement. To a chemist, it is a fine powder of limestone and clay, and nothing more. To the construction industry, it is barely 10% of the thing that actually holds your world up. What is the other 90%, and why has no one ever told you its name? That is the first correction, and it is not a matter of vocabulary. It is a matter of how the built world actually works. Every construction professional knows the difference. Most people never learn it. Start with the powder itself. Cement is made by heating limestone and clay to nearly 3,000 degrees Fahrenheit. What comes out is a fine gray dust. That dust cannot hold up a building. It cannot support a bridge. It cannot even form a proper sidewalk. On its own, cement is brittle. It is porous. It crumbles under the smallest pressure. Think of it as glue. Glue is useful, but glue alone does not make a skyscraper. Here is the rule that follows. Cement is a binder, not a structure. Concrete is the structure. Concrete is the finished material, made by mixing that cement powder with water, sand, and gravel. The cement is only 10 to 15% of the total mass. The other 85 to 90% is sand, gravel, and water. By weight, the thing you have been pointing at and calling cement is almost entirely something else. But if it is mostly rock and water, why does it turn solid as stone? Here the second material breaks your intuition. Concrete does not dry. That word is wrong too. Drying means water leaving. In concrete, the water never leaves. The reaction has a name. It is called hydration. When water touches the cement particles, they do not simply get wet. They dissolve, break apart, and recombine into a gel called calcium silicate hydrate. That gel is the real glue. It grows like microscopic crystals, locking together into a matrix that gets denser by the hour. The water is not evaporating. It is being consumed, absorbed into the chemical structure, becoming part of the material itself. And this leads to something no one expects. Concrete does not weaken with age. It gets stronger. The reaction continues for months, sometimes years. The Hoover Dam is still curing to this day. The Pantheon in Rome, built in the year 120, still holds the largest unreinforced concrete dome on Earth, 43 meters across, after nearly 2,000 years. But the gel cannot do this alone. Cement paste with no aggregate is still brittle. It still cracks under load. The gel needs something to grip. It needs a skeleton. That skeleton is the aggregate, the sand and gravel, and it occupies 60 to 75% of concrete's entire volume. Here the numbers turn brutal. Cement on its own reaches a compressive strength of roughly 2,000 pounds per square inch. Concrete with properly graded aggregate reaches 6,000. Some high-performance mixes pass 10,000. The aggregate is not filler. The aggregate is the load-bearing structure. The rock carries the weight, and the cement only holds it in place. The Romans understood this without any of the chemistry. They used volcanic ash as their binder, and crushed stone and pumice as their aggregate. The ratio was the secret, and it is why their dome still stands. A third material breaks the rule again: mortar. You would assume the stuff holding a wall together is the strongest part. It is the opposite. Mortar is the gray material between the bricks of a wall, and it is deliberately weaker than concrete. That is not a mistake. That is engineering. A brick wall has to move. It expands in heat. It contracts in cold, and it settles over the years. If the mortar were as strong as the brick itself would crack. The mortar is designed to fail first. It is the sacrificial layer. It absorbs the movement and takes the damage, and it can be repaired without tearing down the wall. The numbers are set on purpose. Mortar holds a compressive strength of around 750 pounds per square inch. Concrete for a simple sidewalk holds 3,500. And the reason is one missing ingredient. Mortar is cement and sand with no gravel at all. Without that coarse aggregate, it never forms the structural skeleton, so it stays an adhesive instead of a structure. That is the pattern hiding under all three. The aggregate decides everything. No coarse aggregate, and you have mortar, an adhesive. Add graded gravel, and you have concrete, a structure. The proportion of cement to rock sets the strength. The presence or absence of gravel sets the job. This one idea built the modern world. Joseph Aspdin patented Portland cement in 1824, after baking limestone and clay in his own kitchen stove, and finding the powder hardened underwater. He named it after the pale stone quarried on the Isle of Portland in England. But the Romans had beaten him by nearly 2,000 years. They mixed volcanic ash with lime and seawater, and the reaction gave them a binder that set underwater. It also gave them a dome that has outlasted every empire since. The scale today is almost impossible to picture. The Portland Cement Association reports the world produces over 4 billion tons of cement every year. That becomes roughly 20 billion tons of concrete, the second most consumed substance on the planet after water. 7 billion cubic meters are poured every year. That is enough to wrap a wall 30 feet high and 30 feet thick around the entire equator. You are living inside it right now. Here is the whole correction. Cement is the binder. Concrete is the structure. Mortar is the adhesive. Each one is the same chemistry with a different amount of rock. Change the aggregate, and you change what it can hold up. You started this by calling a gray powder the wrong name. You now know why the professionals corrected you, and you will never look at a sidewalk, a wall, or a bridge the same way again.